This is arguably the most satisfying way of building your first synthesizer. This is called a Simple Fix board, and it has a Daisy seed on top of it. The Daisy is a microcontroller that you could program with Max MSP, Pure Data, Arduino, and it could sound like this. Sound like this. This little thing is actually a sampler. And there are a bunch of companies using it because it's quite remarkable. In this video, we're going to be talking about the tools you need to get started with DIY. We're going to learn a little bit about soldering. You're going to learn how to program your first instrument. And from there, you could go to the beginner's course that's included in the kit. Let's get to it. The Simple Fix board is this, and it comes with these 3 trimmers. So the kit itself comes with 4 trimmers, so there is an additional 1 extra, and a switch. It also comes with a 3-position switch, so it's called an on-off-on switch, while this is only on-off. And it comes with 2 jacks, one for the output and one for the input. This is basically a simplified version and a fixed version of the simple board, which allows people to really build complex instruments like this one. When I say complex, this is actually not that complex in terms of build. Allow me to show you. This thing that you're hearing in the background now is this beast of a synthesizer that is basically just a bunch of knobs. And it is missing the microcontroller, the Daisy is coming here. But there are no analog electronics here. This is simply knobs interacting with a microcontroller. And it sounds like... But we're not going to be talking about this now. This is a bit more of an advanced thing, and that's the nice thing about a platform like this. It allows you to expand and to grow, but we're here to talk about this little guy. So in this video, we're going to be looking at how we start with this and actually make a little oscillator that oscillates and changes the frequency. Let's get to it. All right. Okay, so just a quick overview of what we're going to be doing here. I have some solder here, some solder wick, a soldering iron, and cutting pliers. Let me get my controller here so we can zoom in. First thing first is to add some solder on our tip. Your soldering iron should always look a bit shiny like this. And now when we look at our board, we can see that it actually says there's a bit of like a manual here. And here it says, do not solder on this side. That is because of the connectivity internally. So the first thing we're going to be doing is to put the headers, the female headers. And we're going to be soldering, first of all, just the edges, the edge pins, just to ensure that our headers are sitting straight, because when we put our microcontroller, we want to make sure that it is actually standing straight or sitting straight. Is it standing? Lying straight? I guess it's lying straight. Now let's have a look how it looks like. Is this... Yeah, this is straight. Straight. Good. So when it is straight, I also want to check that the soldering connections are good on these. And now I can solder the rest. And when I say the rest, I mean we're going to be soldering now all the pin headers. We're going to be soldering all these jumpers. And we're going to be soldering all these jumpers. And this is going to connect our microcontroller into our board. So let's do this very quickly. I'm going to run through this, but just the first one, just to show you how this is done. First of all, my tip. Let's show you. Let me see. Can I focus on this? You see, this is now dirty and dark, and we don't want that. We want the soldering iron to look like this. This is now shiny and clean, and that means that our connections are going to be clean and professional. And the way that we do the soldering itself is when we press on one of these pins for a couple of seconds, and then we warm up and we add some solder. And I'm now on 320 degrees. Then we make a connection just like this. Okay, so you don't want to see any gold, basically. After you soldered, there's no gold. The plating is completely covered with a tin of the solder. When you warm up the bridges, these jumpers, then you need to warm up one of them, add some solder, and then warm up the other one, and you basically are trying to connect the two together. The solder always wants to connect anyway, so it should be fairly easy to do that, and this is how it should look like when it's done properly. It did fill in this additional hole here, but it's not really a problem. I mean, you could desolder it, but it's not very important. These are just additional pins that if you would maybe want to add these headers that are sort of like Arduino, so you could maybe connect here all sorts of sensors and stuff, then you could do that, and then you could I mean, it's a board for hacking, so this is just a way for allowing you to hack and connect more things here. But it's not really a problem now. I can also show you, maybe before we continue, just that now we actually have this connection. Let's see. So I'm now going to be touching here. This is where my this is actually where my jack is going to be connected. So I'm going to touch here. I'm going to touch here, which is where the microcontroller pin 19 is, and we'll see that it actually beeps. The reason it beeps is because now this is bridged, and there's a little trace that goes inside here and touches 1, 2, and 3. So if I would connect here a potentiometer, it will also be connected to pin 19, which doesn't really make much sense because the daisy on pin 19 is an output. So that's why the jacks are placed here, because they're going to be directly connected to our output, stereo out, so it actually takes one of the outputs, but you could also hack a stereo on one of these jacks. Not with this one though, so this is actually a mono jack, but yeah, if you're a bit more advanced, you know what I'm talking about. You could hack it and make it a stereo one as well. Okay. Bum, bum, bum. Now I'm just going to run through this very quickly. By the way, the noise that you are hearing now is because I'm actually using I don't know if you can see this. This is a fume extractor that I'm using here. So when I solder, it sucks the fume towards it. You can get one of these if you're soldering a lot. Then you wanna get one of these. If you're just soldering a little bit, it's not really a big deal. But if you're soldering for a few hours, you might want to get something like this. Let's get back to here. Okay, that's good. So now let's put our soldering iron aside, and we can see that we have the connection on these 4, we have the connection on these 4, and we have the connection on ground here. We have the connection on ground here, and we have the connection on VCC here. our board is ready. And we can now take the daisy seed. Let's put this aside for a moment. I'm going to put the headers with the shorter leg. They're slightly different in length here. So this one is the shorter, and this one on the left is a bit longer. And I'm going to put it like this. And once it's inside, I can use my trusty nails to basically twist and break it. For the other header, let me show you another way of doing this. So I can do 1, 2, 3, 4. This is the length that I need, so I need to take 4 out. And I'm just going to use my cutter to take it out. So this is another way of trimming your headers. And now when I have these headers, what I like to do is to simply put them with the long side inside of the board, like so. And stick my microcontroller on top, like that. Now I can press in. And this requires some force, and that's good because this means that there is a good connection here inside. And now the microcontroller is sitting correctly, it sits straight, and we're going to be soldering these pins. Again, we're going to be starting from the edge pins, and then we're going to continue to the rest. There is one important rule here: we never cross solder. So you never are going to be soldering like this. You always solder on this side, and then you flip it to the other side and you solder on this side. You never cross because these components are very fragile and they could melt. All right, so we're going to put some solder on our tip, clean it up, and start here. I'm pressing with my finger on it while it is still warm to make sure that it is stuck straight. I'm going to do the same thing here. That looks good. I'm going to flip it to the other side. And let's double check. So this now seems to be straight. That's good. And I can continue to solder the rest. I'll speed this up for you, but keep in mind that this should take you some time to solder this. You need to be gentle and mindfully solder everything, because your microcontroller is the brain of everything you're going to be doing later on. All right, now that our microcontroller is soldered properly, we can continue to the other components. If you want to take out your microcontroller, you want to use a large screwdriver. Let me see if I have one here, and stick it under and very gently lift up on both sides, because you see the pins here are very gentle, they're really thin. So if you are going to pull on this really hard, you might break them. Okay, so now that we have this, what I want you to do is to get your jack. And we are going to connect the jack in 45 degrees, just like that. We can get our second jack as well and put it here. One of them is connected to the output and one of them is connected to the input. And let's flip to the other side. Now, the pins we want to solder are 1, 2, 3, 4, but you actually don't necessarily have to solder all of them. The way that I do this is I solder this one, and let's do this quickly, because that's basically the active pin. That's the one that we interact with when we send signals to it. That's the one. So I'm going to connect these two. And this one also. Now you might ask, but what about the other ones? Well, in this case, it doesn't really matter. You could actually connect all of them. But in case you would want to disconnect a component, let's say that you actually work with a large simple board, if you connect all 4, it makes it much harder to take the component out. It's not impossible, but it requires skill. If you only connect 2, it makes it much easier to desolder components. So these 2 are essential because one of them is connected to ground and one of them is connected to the active pin. So make sure to solder them, but you don't necessarily have to solder the other 2. Okay, now that we have this connected, we can also connect the switch. Let's put the switch at the bottom here. And the way I do that is actually, let me show you a trick. If you want to solder a switch really quickly, what you want to do is to take one of the pins and just put some solder on it. You don't need a lot of solder, but you do need some solder. There you go. Like this. Now you take your switch and you place it inside, and it won't really go through because it has solder, but then you warm up this pin. And it will go in just like that. This makes it easier now to hold it in place and keep it straight. You want to make sure that these pins, I don't know if you can see them. Let me try to use my light, right? You see these 4 legs, the red ones? They should actually be touching the board, all 4 of them. And now that they are, I can solder the rest. Okay, let's have a look. That's good. So I have now an on-off switch. It is connected properly. And I can connect the 3 potentiometers. So let's do that very quickly. Again, the way we connect them is we put them like this. You might need to bend these legs a bit. These are what we call standoffs, and they're actually not connected to any electronics. I mean, it's not really connected to the circuit, but it holds the potentiometer in place. And because the potentiometer is a mechanical component that we move and turn, these pins are not going to be strong enough to hold it in place. So that's why we have the standoffs. There we go. I have now all of them connected, and all I need to do is to, again, I'm not going to solder those, because if I would want to take them out, it would make it easier for me if they're not soldered. And I'm just going to be soldering these 3 pins for each potentiometer. So 1, 2, and 3. There we go. Our board is ready. This is how our board should look like. Of course, you can design basically the side. You could put another switch here if you would like, or all 4 trimmers. It's up to you. But this definitely should be your outputs. If you're a bit more advanced, you could play around with different layouts. Congratulations. Let's see if we could actually run one of the example pieces of code on this. So let's get to the computer. Okay, so we have our board connected, we have all the components and the daisy seed. Now we're going to take a micro USB cable and make sure that this is a data cable and not only power, because many of them are. This is a data cable, and once it is connected, it should turn this LED on. Once we have that connected like this, we can press boot and reset. You can see, if you look carefully, you can actually see it actually says here boot and here reset. So boot, reset sets up the daisy into boot mode, which basically allows you to upload new programs on it. And what I want to do now is to show you how you could continue with programming. First thing first, you can actually go into the Synthux Academy website and join the community. When you join the community, it'll take you to Discord. And Discord is basically a chat room where we could talk about different things and we could share different ideas. So you can meet a lot of fantastic people here, a lot of creatives, makers, designers, engineers, ask questions. If you're not familiar with Discord at all, it's really nice because you could also go to other communities. So this is the Daisy community, this is the KiCad community, this is the Winterbloom community, this is the fantastic Chompy Club community, Arduino, Maximus P. It's a fantastic place to meet people and to connect. So go ahead and join. Second thing is you want to go into the manual. So if we go to the Simple Synth page, you can actually see here resources. Click resources and go here. There is a manual. If you click the manual, you're going to get to this page. The page includes all sorts of pieces of information, and you also have access to the video course. So you can go to learn.synthux.academy, where you can find the introduction course that covers everything from installing the right programs to programming and building your first subtractive synthesizer, understanding the fundamentals of the daisy seed and how to work with a library. The course is included in the kit that you bought, so you should get an email with login instructions. All right, with that out of the way, let's go to the Arduino IDE to try one of the example codes and see if our board is actually working. Let's go to File, Examples, and let's just run an example piece of code, Daisy Arduino, seed, and oscillator. If you don't see this, this means that you did not install the Daisy on your computer. If you did not install the Daisy Arduino library and the IDE, you want to go into the video course and this lesson here, set up an installation. It's also on YouTube. If you go to our YouTube channel, then it's this video, installation and setup. Here I explain step by step how to install and program the first test of the Daisy. But for now, I'm going to continue. This is where we're going to find the seed oscillator example. And let's close this, double click this, and we pressed boot reset, right? So we can do Command U or Control U on Windows. And it's going to compile the sketch and then upload it on here. If it all works, this should send a signal through this output, and this will control the pitch of our oscillator. Let's wait and see. Note that the reason this is going to be working immediately is because it's connected to A0, and A0 is this pin, is this pot. So there you go, we can actually hear an oscillator working. So to continue, go on the manual and start following some tutorials on the video course, go to our GitHub page, to examples, for example, and try some of these examples. There is a looper here and a multi-voice drone and lots of other examples. But if you're completely a beginner, go to the video course, which is included in the kit. Good luck. I'll see you on Discord.